Nearly everything we do is driven by code. Every line you write, or don't write, makes a difference. The choice is yours.
Greetings. It's a great pleasure to be here. Thank you for coming, and thank you for the organizers of JFall for having me here. It's my pleasure to talk about the new excitement around the good old Java. It's quite hard to believe that this year, Java has just turned 25 years young. Java certainly has come a very long way. Well, I am one of those guys on the other side of the picket line who was constantly complaining that Java is moving too slow. And the change for me in Java started happening in Java 8 with the excitement around the functional style of programming features introduced in Java. Of course, Java 7 brought modularity with a lot of other features and so many other developments that's happened over the years since then. But I couldn't be more excited about Java, and that's what I want to share with you today. Well, the evolution of Java in the past few years has been really phenomenal. I want to talk about what happened recently and where it's heading and why I'm so excited about it. And I hope you would share the feelings with me as well. Well, in terms of the release cadence of Java, well, a lot of people had quite a bit of doubts about this. And Java is now being released every 6 months, a release in March and a release in September. So the question is, how's it going? How's it working? Well, first of all, the release cadence of Java was really not about you and me. It was about making the development of Java agile. Well, the true word of agility is, after all, that, isn't it? Adapting to change and to really move rapidly based on relevance. Who wants to really release something once in 4 to 7 years anyway? Well, definitely not the people who are behind true agility in that sense. Well, Java has been working in a release of 6 months a cycle, but it's really important for us to keep in mind that Java is not being developed in a 6 month cycle. It is being released in a 6 month cycle. So the development is taking as much rigor and time and discipline and innovation as needed. But when something is ready and available, it doesn't have to artificially wait for some other features to be released with it. It can be released within the next 6 months. So the question is, how's it going? Well, it turns out it's going really well. The innovation is accelerated. The developers behind the Java language are, generally speaking, very happy with the pace of innovation and the freedom they get to be able to dive in and implement and seek feedback and adapt based on the realities and then release on a timely manner. One of the best parts of this is to be able to release a feature and see it being used soon enough and not have to wait for 7 years. Well, let's talk about some really interesting features over the past few years that's been introduced in Java. Well, the very first thing is switch as an expression. Well, I smile at the word expression versus the word statement, which is so grim after all, isn't it? So what about an expression? Let's take a look at an example of where this takes us. Well, here I have a function called process that I'm calling with different values, 1, 2, and so on. But I want to be able to process these values. Well, notice the word switch that I can put right after the word return. That couldn't make me any happier. So switch as an expression rather than a statement. I don't like statements as much because statements force mutability to perform their action. Statements, on the other hand, can return values. It turns out in functional programming languages, we have expressions and not as much statements, if you will. So in here, we can say case, and we could say if the value is a 1, maybe I want to return simply a 1. On the other hand, if it's something else, we will simply say whatever and return that particular value right in there. Well, that seems like a very simple example of a switch expression that we could use in here. Of course, this is going to be default in the case of Java, and you can see it says 1 and whatever for all the other things. But you're also welcome to put multiple values in here too. For example, you can say 2 or 3 and return that value for 2 or the value 3, if you will. Similarly, if the value were a 4, and maybe you want to really write a multi-line expression over here, do some processing, further processing over here. And then, of course, you can yield maybe a 4 or whatever the result may be, and you can implement that as well. So this gives a nice flexibility for us to write expressions, doesn't promote mutability. And of course, as you may have noticed, we have an automatic break. And so we don't flow through the next part and mess up the code and the logic behind it. So this is really a nice welcome addition to the language. I could not be happier to see the switch expression. But what I'm even more happier is where the switch is going to eventually grow into. Oh, that we will talk about a little bit later. Well, of course, moving forward, we also have what I would like to call as a smart casting or an instance of pattern matching. So what does this really provide for us? We all have written code like this, something that we are not too happy with, and yet we have actually done over the years. And that example of that is I have a process function I call with a 1 or with the string hello. Now, if it's a 1, we check for it, return, got a number. If it's a string, we say got a string. But I would like to say the size of the string, let's say. Well, what did we have to do in the good old Java? You would say got a string of length, and then after this, you may want to put the length, of course, but you cannot get the length so easily after all. So you would say, for example, length is equal to, and if you had tried input.length, you would obviously get a compilation error because you cannot call the length property on the particular object. So what you would have to do is to go through here and say a string, and then you would take the input, and then you would have to put a few more parentheses, looking almost like a Lisp language syntax, and then execute the code. Now, if you ask the question, what did we do here? Well, some people call it casting, but I call it actually as punishment because we were punished in the programming language to do things that don't really go well. You know, this is like talking to somebody. I hope you wouldn't continue talking to them. Like you go to them and say, hey, did you go to the movies yesterday? And they say, yes, I did. And you ask them, how was it? And they're like, how was what? And you're going to shake your head and walk away, isn't it? Because you would expect good humans to maintain context of conversation. So in this case, you said, did you go to the movie yesterday? And then if you say, how was it? We know what the word was it means in that context. Well, this is where the smart casting really comes in. So what we can do is simply say stir over here, and then go ahead and use that variable stir right in here for the expression. So in other words, you can ask Java to perform the casting. And if the casting were successful, to define a temporary variable, a reference of type string, where that reference really refers to the same object input, just a different type of the reference. So the type casting happens for us automatically. You can use that not only in this condition, but also in an expression where after this you can say and then you can use an str or and an str and so on. So the language begins to feel like it's intelligent. So at some point I always ask the question, do you work for the compiler or does the compiler work for you? Well, more and more in recent years, the Java compiler seems to be working for us, whereas in the past, we were working for the Java compiler. So that's definitely a nice maturity of the language. That takes us to one other feature. We all have written code like this in the past, but nothing ever to be proud about. And that is, suppose we have a function called greet. Now, within the function greet, we want to create, let's say, a multi-line string for a message. So I'm going to say string message is equal to, let's say, hello there, for example. And then we want to write another line of a message. So we may say message plus equal to, and then we could say, how are you today? But maybe we really want to put that into a double quote in itself, and we will start putting escape sequences around it. And then you go on to say plus equal to, welcome to this, to this wonderful, conference and so on. Now, code like this doesn't really make anybody proud. I mean, would you ever put that on your resume saying that I wrote code like this? No, that's a code we hide from humanity. If the children walk into the room, you close the monitor because you never want them to see this code and say, my goodness, that's what you do for a living. and the younger generation would never take up after us for programming. Well, good news, we can use text blocks and get away from writing such ridiculous syntax. So what we could do in here is string, for example, message is equal to, and we can readily write a multi-line string, as you can see right in there. So one of the beautiful things about a multi-line string is this string is processed at compile time and not at runtime. Let's talk about innovation of Java. Here, docs, as this is called in other languages, text blocks, are in multiple different languages. I've used them in several different languages. However, Java, for its own share, did not just embrace here docs and bring it over, but had some innovations built into it. For one, this is processed at compile time. So at the end of the day, what you're dealing with is a string object, a plain old string object, and nothing more. So there's no different type or data type being created behind the scene. So there's no runtime overhead, if you will. And in this case, of course, I'm going to simply say hello there as a string that I've created right in there. But on the next line, I could say, how are you, with no ceremony of escaping, as you can see over there. And then finally, of course, on the next line, I could say, for example, we could say, welcome to this wonderful conference, and then we could write more. So in this case, we wrote a multi-line string without any big deal, without any ceremony. But one of the nice things about the smartness here is the amazing algorithm to detect the indentation. So Java was smart enough to realize that that really was not an indentation we intended. And so as a result, when you notice the output, there's no indentation on the output. However, if you do indent over there, it carries that indentation, as you can see right in here. But of course, in this case, if I really wanted to show you this, I can have spaces over here, but those spaces are not carried forward. Now, those are removed automatically. So if you were to copy and paste the string from somewhere else, that's not carried over. Now, obviously, how do we really prove that it did not carry over? Well, we could do a replace over here and take an empty space and put a little squiggly in it. So you can see there is no squiggly after today in the end of that string. On the other hand, if you do want to preserve it, you can put a little /s, and you can see the squigglies up here right there right now. So that's an example of how the text blocks are processed internally very intelligently, as you can see. And of course, the next thing to excite me is records. Records are pretty amazing for what they can do. Let's take a look at an example here. I've got a location written as a class, but this is relentless, as we know. First of all, when I try to print this out, it prints something absolutely useless, as you can see right there. Secondly, we will end up writing the fields, writing getters and setters and constructor, and then God forbid if we have to write equals, we have to write hash code method, and then of course a toString method, and by the time we are done, we forget what we set out to do. I am a big fan of not having to write code that the language can help us behind the scenes. Now, sure, you could use third-party libraries to do all of that, or you could use fancy IDEs that will vomit the code for the getters and setters for you. But why do all of that? Use IDEs that are good at vomiting, or use libraries when the language can be smart enough. That's exactly what we're going to see in here. So we are going to take that away for a minute and convert that to a record, if you will. And in this case, we will simply say, this is going to be a double latitude and a double longitude right in there. So by having to be able to write that in there, we are able to use the preview feature in here and provide the record in this case. And the record itself is implemented for us nicely, and we can use that. So this gives us a buy one, get 5 free offer, a constructor getters for the properties, which are final, a equals method, a hash code method, a toString method, all of that bundled and available, and we can readily use in this particular case. So that gives us a nice little context for us to use as well. So that is one of the biggest benefits we get out of being able to use a record. Of course, in this case, a record, not a record class. So when I write that code, you can see it says the output for the location is the value that we are expecting. But you can also write a constructor validation here too, if you really wanted to. I have no clue where this location is going to be because it's going to be out of the world, so to say. So I'm going to say try, and I'm going to say new location, let's say 52.31, comma, let's say minus 200.12, which doesn't really make sense. But we could write a catch block, and maybe we could say illegal argument exception, if you will, and then we could ask for an exception to be thrown from this code. Now, as you can see, we didn't write an explicit constructor, but that does not stop us from writing code to really process this properly. So in this particular case, if I were to run the code right now, you did not get any exceptions. But what you could do is to say public location, and in here you could say if the lat is less, greater than 180, and maybe you could even say math dot absolute value of the latitude is greater than 180, or the math dot absolute value of the longitude is greater than 180. You could pretty much say throw new let's say illegal argument exception, and you could put whatever threatening message you want to put in there to process that, and you can see that exception pop up in the bottom with the 3 dots or 4 dots that I put in. So that's an example of creating records, which really removes the burden from our shoulders. And finally, I'll touch upon the sealed classes. Sealed classes are quite awesome in that when we talk about abstract-based classes, an abstract-based class is a class which cannot have any direct instances. A final class cannot have any direct, all right, let me start that over. So an abstract class cannot have any direct instances. On the other hand, you can have child classes, derived classes inherit from abstract classes. Final classes, of course, can have instances, but you cannot derive from them. Now, put them on the scale. Final cannot have any derived classes. Abstract can have any number of derived classes. What if you want to strike a middle ground based on the concepts of algebraic data types? So you may want to create a set of classes, a hierarchy, but it's a closed set. You decide as an author of an abstraction what the subclasses can be. For example, let's say I have a traffic light class with me. So I'm going to edit a traffic light class, or an interface in this case, could be either one, but I have a red light and a green light and a yellow light as the 3 things listed over here. So when I run the code, the compiler is quite happy with it. But what if I were to come in and create a class called a broken light, if you will, which implements, in this case, a traffic light that we wrote in the other file. So implements a traffic light, as you can see in here, but maybe I don't want to permit that. I want this to be a compilation error. Well, why? Because I want to limit the author of the traffic light to decide what derived classes could potentially be. So they can say sealed over here. And once they create a sealed hierarchy, then the children of this class are restricted to be within the file itself as a special case. There are a few different variations to it, but that's a good starting point. So when I run this code, you can see I'm going to get an error right there. It says in the bottom, error class is not allowed to extend sealed class traffic light. Now, the reason for that is I am not permitted to write a class outside that file. Or if I do want to write classes outside the file, but within the same module, I can say permits over here and provide a list of classes that are permitted, even though they may not be in the same file, and you can extend it. So sealed classes are really useful to provide this capability of algebraic data types where you can restrict the hierarchy. Why is that important? Well, it becomes a better modeling tool. It also becomes really nice for pattern matching. Speaking of which, let's talk about the things I'm absolutely excited about moving forward in Java. I cannot tell you how eagerly I've been waiting for powerful pattern matching in Java. Java has been moving towards that over the past few years with developments with the switch expression eventually morphing into a powerful pattern matching. Where I'm truly excited about pattern matching is combine pattern matching with not only switch, but combine that with records and sealed classes. What do they provide as a benefit? Well, with records, we can do some phenomenal data extraction. For example, think about a scenario in which you may want to write some code like this. Maybe you have a record called stock, which contains a ticker, let's say, and maybe a price, if you will. Now, in the pattern matching, what you could potentially do is you could write a case where you take a stock, but you extract the ticker and maybe the price, if you will, and you could intentionally give it a different name to say that this could be a holder for extracting the value of ticker from a stock, and maybe this is a placeholder for extracting a price from a ticker. So from this point onwards, you can use ticker for the ticker prices, a ticker name, and the price for the price of the stock. So it can give you deconstruction. I cannot tell you how excited I am to look for deconstruction or destructuring syntax mixed with pattern matching in the future. Similarly, a sealed class mixed with it can give us the benefit that it's going to provide us a set of case blocks where we can make sure all the conditions are covered. We don't need the default after all. If we were to introduce a new class into the hierarchy, in the control fashion, then the pattern matching can give us a compilation error, making the code a lot more safer at compile time and deterministic. Well, but of course, the last thing I will mention here that I'm super excited about is Project Loom. This is going to change the way we think about programming concurrency and asynchrony. And if you have played with coroutines and concurrency in other languages, well, this is going to be a huge difference in Java, where we can use virtual threads or fibers and create not just thousands, but potentially millions of virtual threads in the code. So rather than a thread or task executing, block the thread as well, you have a logical separation of the task executing in a virtual thread and the real thread that's coming to execute it. So when a task is executing, if the task has to hold and wait for a response, the underlying thread is detached and can be reused while the task in a virtual thread waits for the response to come back. So if you're developing a lot of I/O bound applications in the world of microservices and reactive programming we live in, that makes a lot of sense to look forward to something along the lines of Project Loom and look at fibers. So I talked about a few things that are really exciting to me, and the recent developments in Java, the release cadence, the features, they're all absolutely exciting to me. I cannot wait to really get my hands on some of the newer features that are just around the corner. And Java is not only heading in the right direction, but I think Java is growing in a responsible manner. They're not just moving the language for the sake of moving it. They are looking at the features in a very pragmatic terms, and they are bringing in features that truly make sense to the Java developers and the Java ecosystem, something that can be sustained in the long term and can be and they're implementing it with good performance and keeping us, the programmers, and the applications in the enterprise in mind. So I'm all excited about where Java is heading. I hope you too are excited about it. Thank you so much for this opportunity to speak. I am delighted. I'm going to hang around for the next several minutes to answer your questions or hear your thoughts. Thank you very much.
Code is everywhere. You get up with it in the morning. You take it with you on the go. It brings us closer to one another. It makes life easier, nicer, and it allows you to discover the world, make new connections, realize ambitions. It may even save your life. Nearly everything we do is driven by code. Every line you write, or don't write, makes a difference. That's why we write code that contributes to a better world, that helps shape a sustainable food chain, that empowers people to become financially self-sufficient and gives people back control of their data. Whatever you dedicate your talent to, or don't, makes a difference. The choice is yours. What difference will you make?